All right, so let's quickly go over what is going on with pHs. And pHs that we will learn certainly has to do with the concentration of the hydrogen and the hydroxide ions. And as it turns out, the hydrogen and hydroxide equilibrium has what's called an equilibrium constant, which is to say water sort of spontaneously breaks down into H plus and OH minus. And it does such that the equilibrium constant is always 10 to the minus 14, which is to say that the concentration of the H plus and the OH minus multiplied by each other always equal 10 to the minus 14. That is very interesting thing to happen for us. So let's look at this for a minute. So if our hydrogen concentration is 0.1 and then say 0.01 and 0.001, right? So we're making it more and more dilute, more less concentrated hydrogen here. What we're basically doing is saying that the next one will equal whatever the one before it was divided by 10, right? Because let's let this computer do some work and then we can go down. Whoops, starting, where's my X? I want to make my X. Oh no. Why is that not working? Oh, there it worked, even though it's... Anyway, so as you can see here, the computer thinks that's a 0 because it's such a small number, but if I show enough significant digits, it'll finally show the 1 by clicking on this. And same thing here, it thinks those are zeros, but if I show enough significant digits, it will finally reveal that there is a 1 there, way, way, way back. All right, so I think I've gone too far, but anyway, this does not work with Screencastify very well. Interesting. All right, so then, hopefully I'm still recording. The OH minus we just learned, right? We just saw here is equal to the concentration of H plus as a denominator to 10 to the minus 14. So 10 to the minus 14 divided by the H plus will equal the OH minus. So we can fill all these in as being equal to whatever that is. Oops, nope, is equal to the 1 times 10 to the minus 14, which in computer language is 1e minus 14, divided by whatever's over there. And we hit enter. And as you see, that 0 tries to come up, and then we drag this down. And the same situation occurs here, where if I show enough digits, you'll see the ones, right? And the relationship then means, because they're equal to a constant, that they... I don't guess I'm going to be able to do that. Anyway, as one gets smaller, the other one gets bigger, right? And that's the beauty of a constant like equilibrium. And if you look here, if you look here at water, that's what's going on here. So there's a whole bunch of water, but only a little bit of it is going to H plus and OH minus. And if we introduce a strong acid, that's going to heavily favor the H plus, and there's going to be very little OH minus. And if we put in a strong base, it's going to very heavily push the OH minus, and there's going to have to, as a result of that, be very little H plus. So the pH, which comes here, and we sort of explored about what those mean and how water is at 7 and strong acids are at the low, acids are in the lower numbers and bases are in the higher numbers. And why is that? That has to do with log. So the pH, it turns out, as you know, if we take the log of, if we say that this is equal to the log of whatever's the concentration of H is and hit enter, it would be -1. And that's because what log means is this is 10 to the -1. And log says, well, what power is 10 to for this to happen? Like, what did 10 get raised to for this number to occur? And the answer is -1. What number did 10 get raised to for this to happen? The answer there would be, let's see if that'll work. Does it figure that out? Yeah, -2, right? Because that's 10 to the -2. So 10 is raised to the power of -2. That's what that means. So when we're doing logs, it just says 10 to the what equals the number that's here. And here it's 10 to the -3 equals the number that's there. So this is nice, right? We have all these negative But nobody likes negative numbers. So what we've defined pH as is the negative log. So that equals the negative log of whatever is the concentration of H plus. And so now we have nice positive numbers, right? 1, 2, 3, 4, 5, nice positive numbers because we define pH as the negative log. So whatever this would be, make it negative. So that's 10 to the minus 1. That means 10 was multiplied by, to the power, or not multiplied, was raised to the power of minus 1. So we just negate that to make it a positive 1. This is 10 to the minus 2. We negate that to make it positive 2. And on down. So as you see, the reason why pHs of basic solutions are very high is because the concentration of H plus is very low, and therefore the concentration of OH minus is very high. Whereas the pH of acidic solutions is very low, these 1, 2, 3, 4 areas, because the concentration of H plus is very high compared to the OH minus, and thus the 10 to the minus thing would be a very low number. 10 to the minus 1, 2, and 3 would be high concentrations of H plus. And remember, right, this is the computer thinks this is 0, that there's essentially no OH minus in there. That's why the pH would be 1. So that is an explanation of pH. And if you think about it, if you have in an egg for Easter a certain number of M&Ms, let's say, what did I go with? I went with 48. So if I can fit 48 M&Ms into an egg and I can only fit white and yellow ones, every time I take out a white one, right, I need to put some yellow ones in to make the total 48. So having things equal to a constant, as the equilibration of water is, the fact that this equals a constant is not unlike the fact that this Easter egg can only hold 48 M&Ms, and every time I take a yellow one out, I can put a white one in, and every time I take more yellow ones out, I can put more white ones in. So as one gets smaller, the other one gets bigger, so that the total equals 48. So you have this inverse relationship between things that are related to by a constant when they're multiplied by each other. So that is pHs, right? I think that's everything. I don't think I need to talk much more about that. But basically, you're going to need to embrace the log function, okay? Log of any number 10 to the power of something is basically saying, what do I need to raise 10 to the power of to equal this number? And in that case, it's minus 5. In this case, it would be 43. In this case, it would be smiley face. So that is what log is. And pH is defined as the negative log because then instead of having these negative numbers, we have positive numbers. That should be helpful to you. So if we're practicing here, which I don't have my pen because I'm a knucklehead, but if we're practicing here real quick, I have to start, let's do it in red, right? 1 times 10 to the minus 1. The log of this is what do you multiply, what do you raise 10 to get this number? And the answer would be minus 1. And so log of H plus would be minus 1. And if we negate that, we have plus 1. And therefore, the pH would be plus 1. And here, that's 10 to the minus 3. So what do you have to raise 10 to get this number? And the answer is minus 3. And if we make that negative, it would be plus 3. And therefore, the pH is 3. Right? So basically, whatever the number is here, you make it positive because we changed the sign by saying it's the negative log. And then pH would just be equal to that. So as you can see, pH of 7 is when the concentration of H is 10 to the minus 7. pH of 10 is when there's barely any H plus, and pH of 14 is really very small amount of H plus, so therefore not acidic at all, very basic. All right, and that is shown here by the concentration of H plus is very high when it's a low pH, and the concentration of OH is very high when it's a higher pH. And if we make them logs, it just looks like a prettier graph than instead of this thing, which is more asymptotic, if I believe that's correct. All right, that's all I'm going to talk about there. I'm done with this. Discard. I am now going to do something else, which I don't even remember. All right.